Today we'll go through special purpose robots. Number 1. Leo. Researchers at Caltech have built a bipedal robot that combines walking with flying to create a new type of locomotion, making it exceptionally nimble and capable of complex movements. Part walking robot, part flying drone, Leo is the first robot that uses multi-joint legs and propeller-based thrusters to achieve a fine degree of control over its balance. Bipedal robots are able to tackle complex real-world terrains by using the same sort of movements that humans use, like jumping or running or even climbing stairs, but they are stymied by rough terrain. Flying robots easily navigate tough terrain by simply avoiding the ground, but they face their own set of limitations: high energy consumption during flight and limited payload capacity. Robots with a multimodal locomotion ability are able to move through challenging environments more efficiently than traditional robots, and this by appropriately switching between their available means of movement. In particular, Leo aims to bridge the gap between the two disparate domains of aerial and bipedal locomotion that are not typically intervened in existing robotic systems. By using a hybrid movement that is somewhere between walking and flying, the researchers get the best of both worlds in terms of locomotion. Leo's lightweight legs take stress off its thrust by supporting the bulk of the weight, but because of the thrusters are controlled synchronously with leg joints, Leo has uncanny balance. Based on the types of obstacles it needs to traverse, it can choose to either walking or flying, or blend the two as needed. In addition, Leo is capable of performing unusual locomotion maneuvers that even in humans require a mastery of balance, like for instance walking on a slackline and skateboarding. Our friend Leo stands 2.5 feet tall and is equipped with 2 legs that have 3 actuated joints, along with 4 propeller thrusters mounted at an angle at the robot's shoulders. Number 2. Swarm robots. As a robotic engineer, Yasemin Özkan Aydın, assistant professor of electrical engineering at the University of Notre Dame, gets her inspiration from biological systems, the collective behaviors of ants, honeybees, and birds to solve problems and overcome obstacles is something researchers have developed in aerial and underwater robotics. Developing small-scale swarm robots with a capability to traverse complex terrain, however, comes with a unique set of challenges. In research published in Science Robotics, Özkan Aydın presents how she built multi-legged robots capable of maneuvering in challenging environments and accomplishing difficult tasks collectively, mimicking their natural world counterparts. Legged robots can navigate challenging environments such as rough terrain and tight spaces, and the use of limbs offers effective body support, enables rapid maneuverability, and facilitates obstacle crossing. Individual robots performed simple or small tasks such as moving over a smooth surface or carrying a light object. But if the task was beyond the capability of the single unit, the robots physically connected to each other to form a large or multi-legged system and collectively overcome issues. When ants collect or transport objects, if one comes upon an obstacle, the group works collectively to overcome that obstacle. If there's a gap in the path, for example, they will form a bridge so the other ants can travel across. And that is the inspiration for these robots. Using a 3D printer, Özkan Aydın built 4-legged robots measuring 15 to 20 centimeters or roughly 6 to 8 inches in length. Each which was equipped with a lithium polymer battery, microcontroller, and 3 sensors. Now, a light sensor at the front and 2 magnetic touch sensors at front and back, allowing the robots to connect to one another. 4 flexible legs reduced the need for additional sensors and parts and gave the robots a level of mechanical intelligence, which helped with interacting with rough and uneven terrain. Number 3. Bladebug. Robots aren't going to take over the world. I mean, I can't promise that, but they can definitely make life a lot easier for humans. And that was the aim of Bladebug, a UK startup that has developed insect-like robots to inspect, maintain and repair offshore wind turbine blades without the need for rope access. As the offshore wind industry enters a rapid phase of growth, the challenge to keeping turbines spinning and optimize grow with it. So, Bladebug is developing advanced robots to assist technicians in the inspection and repair of turbine blades without the need for rope access. The robot can be operated out of the line of sight, meaning technicians can remotely perform maintenance tasks without the associated cost and without being exposed to harsh conditions. The speed of deployment and ease of use means teams can treat defects before it would be viable to use a traditional rope access team. This preventative maintenance increases the efficiency of the turbine and maximizes the low carbon energy generated. The modular design of the robot body can accept different non-destructive testing and repair equipment, making it flexible while offshore. Bladebug founder Chris Cieslak became convinced that advanced robotics could transform operations at offshore wind farms, reducing costs and maximizing asset lifetimes. Number 4. Facebook BombX robot. Facebook Connectivity thinks it has developed a cheaper and faster way to deploy fiber that doesn't involve digging up streets. Instead, the company has created BombX, an aerial fiber deploying robot that crawls along power lines and wraps fiber around those lines. The company envisions BombX being used as a middle-mile fiber solution, meaning it can bring fiber capacity to a pole amount, and from there, a service provider would either have to use underground fiber or wireless for the last mile connection. As a refresher, Facebook Connectivity is the part of Facebook that is tasked with working on technologies and partnerships with the goal of bringing the internet to more people around the world. Half the world's population still remains unconnected to the internet and are excluded from the huge social and economic benefits of it. Slamcore is proud to be one of the contributors in Facebook's development of BombX, an aerial fiber deploying robot that aims to make fiber deployment significantly more economical. Named after the silk-spinning BombX silkworm, the robot is designed to climb along electricity distribution lines, wrapping a new lightweight fiber optic cable to bring fiber internet connectivity to more regions of the world at a fraction of the cost. BombX is designed to be fully autonomous, moving along power lines and climbing around obstacles to lay kilometers of fiber optic cable without the need for human intervention. However, Facebook admitted that one of the big disadvantages faced by power companies that are deploying aerial fiber is that these companies typically have to interrupt the power service to homes and businesses during the process. Number 5. Bionic Bird. The bionic birds are agile, maneuverable, and can even fly loops and steep turns. By interacting with a radio-based indoor GPS system, the 5 robotic birds are capable of moving autonomously in a coordinated pattern in a defined airspace. When designing robotic birds, the focus was on the use of lightweight structures, just like their biological role model, because the same applies in engineering as it does in nature, meaning the less weight there is to move, the lower the use of materials and energy consumption. And so, with a body length of 44 centimeters and a wingspan of 68 centimeters, the bionic birds weigh just 42 grams. To execute the flight maneuvers as true to life as possible, the wings are modeled on the plumage of birds. The individual lamellae are made of ultralight, flexible, but very robust foam and lie on the top of each other like shingles. Connected to a carbon quill, they are attached to actual hand and arm wings as in the natural model. During the wing upstroke, the individual lamellae fan out so that air can flow through the wing. This means that the birds need less force to pull the wing up. During the downstroke, the lamellae close up so the birds can generate more power to fly. Due to this close-to-nature replica of the wings, the bionic Swifts have a better flight profile than previous wing-beating drives. The bird's body contains compact construction with the wing flapping mechanism, the communication technology, the control components, the wing flapping, and the elevator, the tail. A brushless motor, 2 servo motors, the battery, the gearbox, as well as various circuit boards for radio, control, and localization are all installed in a very small space. Number 6. Robot Forest Rangers. Industrial design student Segev Kaspi conceptualized a crew of robotic foresters for his graduation project at Shankar College in Israel. With roles including seed planting and data analysis, the Forest Ranger dudes are designed to support reforestation efforts and sustainable forest management, bringing together 2 opposing worlds, nature and technology. Kaspi aims to stimulate conversation on rising atmospheric oxygen and the importance of rehabilitating our forests, all the while proposing a possible solution to the problem. The robotic foresters operate in systems that change in accordance with the forest needs and can work either individually or in groups. Each robot is assigned a defined role in managing and preserving the forest. Their roles and design language reflect a long process of studying the work of rangers in an attempt to gain an in-depth understanding of this important job. The first robot is Chunk, who is responsible for sowing, pruning, and mowing. Then there comes Dixon, who takes care of planting and reforestation of seedling and cuttings. Last, there it comes Rico. Rico gathers, monitors, and analyzes data from the forest. Kaspi has brought the 3 conceptual robots to life through drawings, computer renderings, and physical models. This project was intended to spark a public debate about the concentration of carbon dioxide in the atmosphere and the importance of rehabilitating the world's forests.